Hello students, welcome to the solution question part 5. So in today's session we will solve questions from 34 to 41 that comprises total of 8 questions. So in this question session I will be dictating some questions to you, as well as I will give you 10 seconds to solve this question. So after the 10 seconds, if you are able to solve that question, you can check your answer, or else you can check your approach also. So you know that 10 seconds is very difficult, is very less to solve the question. So I would advise you to use my reading time also to solve the question. With this, moving on to the questions. Before that, we have a disclaimer here. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck, have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. Question number 34. Question number 34 says that when 20 gram of naphthoic acid is dissolved in 50 gram of benzene, a freezing point depression of 2 Kelvin is observed. The Ventov factor is, your options are A 0.5, B 1, C 2 and D 3. So what is being given in the question? The question is saying that we are taking 20 gram of benzoic acid. Okay, we are taking 20 gram of benzoic acid and we are dissolving it in 20 grams of naphthoic acid and we are dissolving in 50 grams of benzene. Now, after addition of this naphthoic acid, the freezing point is depressed by 2 Kelvin, which is saying that this naphthoic acid is non-volatile in nature. Clear? So you will simply use the formula of depression of freezing point because everything else is given. Your Kf is given, your mass of naphthoic acid is given, formula is given. You can calculate the molar mass also, and what else is given? We are given the mass of benzene also, so you can use it to calculate the Ventov factor. Okay, so you must know the formula for Ventov factor. That is the only thing you have to think here. Okay, so your 10 seconds to solve this question starts now. So your time is up. Let us see how can we solve it. For those who have solved, the correct answer is A. Now, the actual molecular weight of naphthoic acid is 172 gram per mole. We know this. And what is the molecular weight that is calculated from this given thing? So it is calculated to be 1000 into 1.72, 20 into 50, 50 by 2. So this is the formula. So 1000 into Kf by W solvent into del TF. So we know that del TF is equals to what? Molality into Kf. Okay, so we have accordingly find the molality, and then to find the molality we need the molecular weight. So we have rearranged this equation to calculate the calculated molecular weight. So in this way you will get this as 344 gram per mole. Now we know that Ventov factor I is equals to actual molecular weight and y calculated molecular weight. So which is actual is how much? It is 172 by molecular, which is 344. So by doing this you will get 0.5 is the correct answer. You can use a other formula also. The formula is same, but it is a more primitive and more understandable one. So it says that delta TF equal to IKFM. Okay, so you can find your whole answer in from the one equation only. From there you can easily calculate your I. So that is a more easy way to solve the question, I would say. So it's your choice further. So your next question is question number 35. Question number 35 says that which one of the aqueous solution will exhibit highest boiling point. So you have options as 0.01 Na2SO4, 0.01 M KNO3, 0.015 molar urea and 0.015 molar glucose. So the hint for this question would be that you have no worries. You have to don't worry about the say nature of the solute. Okay, this nature you don't have to worry. Only you have to see that what is the number of particles that is furnished by this different molar solution, and the one which is furnishing more particles will result in more elevation in boiling point, or will have the more higher boiling point. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see the solution. How can we solve it? So it was saying that which will exhibit highest boiling point, right? So the correct answer is A for those who have solved. So we know that Ventov factor is directly proportional to the boiling point or the number of particles directly, I would say. So since Na2SO4 is giving us 3 ions and KNO3 giving us 2 ions, and urea and glucose are poor electrolytes, so I will be equals to 1. Okay, not 0. It will be equals to 1. Though miss, you don't have to put I here, so it is written 0. You can take it as 1 also, because the actual formula includes I, and since we are having only one particle, so we can take it as 1. And if you are not taking I, then you can take the value of I as 0. Means it has no sense in that. Means the way you understand is the answer you get, right? So is this thing is clear to you? Now next, now since 0.001 Na2SO4 possesses the highest boiling point. It is clear because it has the highest what? It has the highest molarity plus the number of particles that is furnished by one molecule is also more. That is 3. Moving on to the next question. Question number 36 says that a compound X undergoes tetramerization in a given organic solvent. The Ventov factor is, your options are A 4.0, B 0.25, C 0.125, D 2.0. So you have 10 seconds to solve this question. Your time starts now. Before that, the hint would be that since it is tetramerizing, means the particles is decreasing, number of particles is decreasing, and hence the Ventov factor will be always less than 1. So this much hint is, I think, enough to solve this question. Your 10 seconds starts now. Your time is up. Let us see how can we solve it. So correct answer is B. So for those who have not solved, let us see the approach. So since it is going this tetramerization and 4 particles are being produced, so we can say that alpha can be 1. Okay, if degree of dissociation is 100%, if alpha is 1, then I will be equals to 0.25. Okay, so you can take in this way also, since the X is going tetramerization and there is no description of the alpha, so you don't have to worry about it. In case if it is going some extent, means if it was in equilibrium, then there must be a mention of the alpha. Since it is not mentioned, you can directly take the I value as 1/4. Okay, or else you can go through this one. It is a more systematic way, or you can take 0.4 also from your sense. Clear? So from this way your I is 0.25, so correct answer is B. Moving on to the next question. Question number 37. The question number 37 says that the degree of dissociation of a weak electrolyte AXBY is related to Ventov factor I by the expression. Your options are alpha is equals to I minus 1 by X plus Y minus 1. B, alpha is equals to I minus 1 by X plus Y plus 1. C, alpha is equals to X plus Y minus 1 by I minus 1. And D, alpha is equals to X plus Y plus 1 by I minus 1. So 10 seconds to solve this question starts now. So your time is up. Let us see how can we solve it. So the correct answer is A first of all. Again, since it is a weak electrolyte, so 1 minus alpha, it will be X alpha and this will be Y alpha. Now, what is I? It is the total number of particles, so 1 minus alpha, X alpha and Y alpha. You will add these three, that will give you this equation. Clear? Now, next, you have to find the alpha. Okay, the question was saying to find the alpha. So, since this is X plus Y plus minus 1, you just subtract I minus 1 here and divide it by this value. So that will give you alpha. So how we have dissociated it? So since it was AXBY, so it will dissociate into XA having Y plus charge plus YBX minus charge. A charge can be here and there, that's no difficulty. But since we know that first we write the metal, that is the cation, and then your anion. So we have just taken the convention here. Now one particle, initially it was one particle and here it was 0 of this and 0 of this. After dissociation, alpha will break down, and if one means alpha is breaking down, then X alpha will be formed from here and Y alpha will be formed from here. Now you can just move on, that I is what? The total number of particles. So 1 minus alpha plus X alpha plus Y alpha. So that will give you alpha is equals to I minus 1 by X plus Y minus 1. Moving on to the next question. Which one of the following aqueous solutions should have the highest boiling point? Your options are 1 molar NaOH, B 1 molar Na2SO4, 1 molar NH4NO3, 1 molar KNO3. So the hint for this question would be that Ventov factor is directly proportional to what? Ventov factor is directly proportional to the elevation in boiling point, because delta T equal to I kbm. So more is the number of particles, more is your boiling point increase. So the one with the greater number of particles is the concentration of all of these is 3. So you have to only worry about the number of particles furnished by one molecule. So your 10 seconds to solve this question starts now. Your time is up. Let us see how can we solve it. So correct answer is B for those who have solved it. So boiling point of solution is directly proportional to the Ventov factor, I have told you. And since Na2SO4 has 3 particles, therefore we will have the greatest value of I in this one. And hence the boiling point elevation will be higher in comparison to all 3 others. And in case of N2SO4, it will be the highest one. Clear? Moving on to the next question. Question number 39. In a 0.2 molar aqueous solution of weak acid HX, the degree of ionization is 0.3. Taking Kf for water as 1.85 Kelvin kg per mole, the freezing point of the solution will be nearest to A 0.-0.360 degrees Celsius, B minus 0.260 degrees Celsius, C plus 0.480 degrees Celsius, and D minus 0.481 degrees Celsius. So what is being given in the question? Your this molality is given. First of all, you have to calculate what? You have to calculate the freezing point of the solution. Clear? Now since it is water, so you will take 0 degrees Celsius as what? 0 degrees Celsius as the initial say boiling point. Okay, because you have to calculate it in degrees Celsius. And second thing, you have to calculate the degree of ionization is already given as 0.3. So you have to calculate I also. So I think this much is hint is enough to solve this question. Your time starts now. Your time is up. Let us see how can we solve it. For those who have solved it, the correct answer is D. So initially HX breaks into H plus and X minus. So we have initially one mole only, and after, since degree of dissociation is 0, degree of ionization is 0.3, so 1 minus 0.3, and 0.3 of this will be formed, and 0.3 of this will be formed. Okay, so total number of moles will be addition of this plus this plus this. So I will be how much? I will be 1.3 by 1, that is 1. Okay, so it is simply the total number of particles. Now next, delta TF equal to KF I KFM. Okay, so you put this value here. 1 KF is already given, molality we already know. So that will give you 0.481 Kelvin. So this is the change in freezing point. And as we know, 273 is the original one. We can take here 0 directly and find your answer. So they have done it in this way. So you have to calculate it degree Celsius. So they will do this thing at last. Okay. So you see, you have converted to degree Celsius. It is minus 0.481 degree Celsius. So it will be more convenient if you directly take 0 here. So it will give your TF directly minus 0.481 degree Celsius without any conversion. Okay. So in this way, you will solve this question to get the correct answer as D. Moving on to the next question. Question number 40. In comparison to a 0.01 molar solution of glucose, the depression of freezing point of a 0.01 molar MgCl2 solution is the same, about twice, about 3 times, about 6 times. So the hint of this question is that your glucose is a what? Is a non-ionizable salt, non-ionizable compound in water, whereas your MgCl2 is ionizable. So that will result in more number of particles. Okay, so I think this much hint is enough to solve this question. Your 10 seconds to solve this question starts now. Your time is up. Let us see how can we solve this question. For those who have solved, the correct answer is C. So since it is a non-electrolyte, glucose, I have told you it is less ionizable, so it will not go under ionization. Okay, whereas your MgCl2 will furnish 3 ions, which is 1 Mg2 plus and 2 Cl minus, and therefore I will be having 3 value. And for glucose it is 0, means more appropriate will be that if you take I is equals to 1, because that is the number of particle, it is simply 1. So therefore depression of freezing point will be what? It will be 0.01 of MgCl2 will be more, about 3 times, because it is having 3 ions, 3 times than the 0.01 m glucose solution. Okay, so in this way you will solve this question. Moving on to the next question. The freezing point in degrees Celsius of a solution containing 0.1 gram of K3FeCN6, molecular weight 329 gram, in 100 gram of water, that is Kf is given 1.86 Kelvin kg per mole, is, your options are A 2.3 into 10 to the power minus 2, B minus 5.7 into 10 to the power minus 2, C 5.7 into 10 to the power minus 3, and D 1.2 into 10 to the power minus 2. So what is being given? It is being given that a solution is containing this complex, and in what amount? In 0.1 gram. Okay, 0.1 gram of this is given in water, and that is present in 100 gram of water. Now you have to calculate the freezing point of the solution if your Kf is already given. What is given? Your Kf is already given. So how you will solve it? You will simply use the formula of del Tf equal to Kfm. You can calculate a molality using the given mass. You can calculate the number of moles from here, and then you can solve it to get your freezing point. So and also you can take the freezing point of water as 0 degree Celsius, and then you will get your answer easily. So 10 seconds to solve this question starts now. Your time is up. Let us see how can we solve this question. So this was given that we are adding this complex to water, and we are adding 0.1 gram to 100 gram of water. 0.1 gram of this complex to 100 gram of water. The molecular weight is 329 gram per mole, and your Kf is 1.86 Kelvin kg per mole. For those who have solved it, the correct answer is A. So what will be the Vent-Hoff factor? So see, this complex will ionize. So this is the secondary valency, and this one is the primary valency. So primary valency is ionizable. So this will give you 3 potassium plus ions, and the complex will form a whole ion. So that will form total number of 4 ions. So I is equals to 4. Initially it was 1, means ideal case it was 1, and now it is 4. So 4 by 1, that is 4. So this is explained with help of this equation here, that is written down. So I is equals to 4. Now we know that delta Tf is equals to I Kfm. We put the value of I. Kf is given. Okay, so capital K will be here. Okay, that would be more appropriate. So if you put this thing 1.86 here, what will be the molality? So number of the molar mass is given 329 gram, and the mass is given. So molarity will be number of moles dissolved in per kg of solvent. So you will convert this gram into kg, and you will convert this gram into mole. Then divide both of them. On the upon side we will write the mole, on the down side we will write the volume of mass of water. Same thing has been done here. So 100 by 1000, and W2 by M2 will done the next step. So 0.1 by 329. Kf value is 1.86, and I value we have already calculated as 4. Okay. Now next what we will do? We will just calculate this to give the final answer as 2.3 into 10 to the power minus 2 as the final answer. Now what we have to calculate? We have to calculate the actual freezing point of the solution of the solution, and this is the change in freezing point. So don't leave your answer till here. You know that the freezing point of water is 0 degree Celsius. We put this thing here, and we also know that the change is this much. So the freezing point will be how much? Because delta Tf will be what? If you calculate delta Tf, it will be Tf T naught F minus Tf, where T naught F is actual one, means the ideal one, and Tf is the one which is gained upon adding of solution. So you will solve that one to get this thing. So that will give you a freezing point in minus 2.3 in 10 to the power minus 2 degree Celsius. Okay, so this will be your new freezing point. Clear? So very easy to solve this question. Now the question may be asked to know this value in Kelvin. Then in that case, what you will do? You will write here 2.7 273.15 instead of this. This will be as it is. You don't have to convert this. Never convert this. This is the change. Change in temperature is never been converted. You will only change your value in Kelvin here. Okay, and further you can get a final answer in Kelvin. So in this whole question series, the focus was on Vento factor. So you must be able to calculate the I and alpha if you are given the degree of association or dissociation. Okay, so that is the main thing here. And if it is 100% dissociating, like in this case, then you don't have to worry. The number of particles is simply the number of particle into which it is dissociating will be simply I, and if it is associating, then 1 by the number of particles in that are dissociating will be your I factor. Clear? So this is all for today's class. Thank you.